All right, this is the tricky video. We've touched on this topic a little bit, function composition and domain, in previous sections. Well, here we're really going to lay into it. We're really going to show the fruits of our earlier labor and frustration. Okay, so we're going to start with another definition. In 3.4.1, we talked about f plus g, f minus g. Just add them together, just subtract them together, just multiply them together. Well, now we have the fifth one. All right. This fifth one puts the fun in function. And that's f open circle of g, like this. And the definition is that you plug g of x into f of x. So there's a lot to unpack here. All right. This is pronounced f of g. A lot of people will say fog because it's an open circle. It looks like an O, but it's an open circle in the middle. So it's not actually like writing fog. It's more like that. Okay. And then we're going to work from the inside out. Substituting. We'll do plenty of examples, but this can be tricky. So strap yourselves in, find a study buddy, and let's go. So for f of x equals x squared plus 1, and g of x equals to the square root of x, find the following. Part A is going to be, what is f of g of 4? So again, use the definition. Also, important note, right? F of g is not the same thing as f times g. The definition says f of g is f of g of x. So notice the language here, right? When I have something like this, f of 4, we say f, the function, of. We say of to mean we're evaluating 4. F of 4 means f evaluated at 4. So when we even write this notation, f of g, it's f evaluated at g. So we're trying to be consistent as much as we can in the math world. Also, I made a small error right here. We're not talking about x's here. We're talking about 4. So start on the inside. What is g of 4? Well, I know g of 4. That's plugging in 4 into our function g. So you look at g and replace all the x's with 4's. So g of 4 is the square root of 4. Simplify that out. G of 4 is equal to 2. So if g of 4 equals 2, replace it. So this simplifies to f of g of 4, but we know g of 4 is just 2. So replace the g of 4 with 2, and voila, I can't snap with my left hand very well. Voila, the problem is much easier now. Now again, we have to go to the side and say, what is f of 2? Well, replace all the x's with 2's. It's going to be 2 squared plus 1, which simplifies to 5. Again, if f of 2 equals 5, you just replace it. So f of g of 4 is equal to 5. Now let's take this up a notch. Let's find f of g of x. All right, now I want to copy these functions down real quick. F of x was x squared plus 1. And g of x was the square root of x. So in part B, you don't have to copy these down again, but I just don't want to go between pages. Ask you to find f of g of any x. So in the last one, we found what is f of g specifically at 4, and now it's f of g for any input value, any x. So just like before, we're going to start by using this definition of function composition, f of g of x. My cats are going wild right now. F of g of x. And before, remember, we went off to the side and we said, what was g of 4? Well, now, when we go off to the side, there's nothing to simplify or plug in, right? G of x is just equal to the square root of x. But we still plug this in. We replace, just like in the last example, g of x with what it equals. So we still have f. We still have f of g of x. But g of x is the same thing as the square root of x. So this is where things get a little weird. Well, maybe things have been weird for a while, but this is where I'm noticing that they're getting a little weird. All right, a little oblivious here. What is f of the square root of x? Well, so look at f, right? Replace all, we can't really go off to the side here. We just kind of have to do it, right? Replace all of these x's with our input. Sometimes we replace them all with 4s. Sometimes we replace them all with 3s. A lot of times we replace them all with numbers. But now I'm replacing all the x's with square root of x. So normally this is what f of x is. So for f of the square root of x, replace all the x's, or usually it's x squared plus 1, right? That's normally what f is, but now we're not plugging in x anymore. So replace those x's with the square root of x, and then simplify. The square root of x squared, those cancel. We just get x plus 1. This is our new function. This is what f of g is, f composed with g for any input value. So in the first part, we said that f of g at 4 is equal to 5. We can see that here as well, right? F of g of 4, well, this is f of g for any x. So specifically at 4, it's 4 plus 1, just plug it in right here, which is equal to 5. So this is consistent with our answer from A. As a little side note there. All right, and things can get weird here. We can combine these with other things as well. Like if we look at part C, we could look at f of f. It can be the same function. Just use the definition again. F of x. So do the same thing. What is f of x? F of x is x squared plus 1. So take this, and we replace it. So the inside becomes x squared plus 1. Because f of x is the same thing as x squared plus 1. That's what equals means. Same thing. If they're the same thing, we can replace one with the other. And now we look at f and we replace, right? We have x squared plus 1, and we're going to replace all x's with x squared plus 1. So we have this, and each x we're replacing with this. It's kind of crazy. So normally it's x squared plus 1, but instead of x, we're putting in x squared plus 1. We're plugging the function into itself. That's what f of f means. Take the function, plug it into itself. And this is what we get. And then we could simplify this a little bit. Remember, if something is squared, Squared just means multiplied by itself, so it simplifies to this. And then we FOIL. X squared times x squared is x to the fourth. X squared times 1 is x squared. X squared times 1 is x squared. And 1 times 1 is 1. Combine like terms, and you should get x to the fourth plus 1x squared plus another x squared is 2x squareds. 1 plus 1 is 2. This is what f of f simplifies to. All right, which is kind of crazy, kind of weird. And to make matters worse, we're going to talk about domain now. So let's do another property here. The domain, the set of all the input values, the set of all the things we can plug in of f of g is the intersection of two things. The domain of g and the domain of the simplified f of g expression. And now this looks a little weird, especially when I write expression like that. Pause. Don't worry about this too much. Let's see it in action to see what I mean. So we just have to find two domains and find their intersection. It's a little weird, but hopefully it'll make more sense as we do an example. Example 5. For f of x equals x squared plus 1, and g of x equals the square root of x, and h of x, let's add another function in here, why not? 1 over x minus 1. Find the following. I keep writing off the screen. And their domains. Part 1 is going to be f of g. So maybe a quick note right here, g doesn't always necessarily mean g. G just means the second or the inside function. Okay, in this case, g is g. So f of g. Let's find this out. So to figure out what a function is, we look at what that function equals for any x. Using the definition of function composition, this means f of g of x. Take g of x, plug it into the outside function. So just like before, we go off to the side and say, what is g of x? Well, g of x is the square root of x. We did this before. Actually, we did exactly this before, right? We did find f of g for this exact function. And we found it to be, so we'll go through the same steps, but we'll go through them quickly. We'll replace this out. Going to f of the inside function, square root of x. Plug square root of x into f. And we'll get the square root of x squared plus 1, just like before, and simplify to x plus 1. So as before, the function f of g is equal to x plus 1. This is half of our answer. Find the following and their domains. So this is the function. So what's the domain of function composition? The domain of f of g is the intersection of two domains. So we just have to look at two domains and see what they have in common. Well, let's look at the domain of g. So domain of g of x. What's the domain of this function? It's a square root. The domain of the square root is when the inside is at least 0. Well, the inside of this square root is just x. So that's the domain of the inside function. Good. And then we also have to look at the domain of the simplified f of g expression. So that's going to be this. What's the domain of this simplified f of g expression, x plus 1? What's the domain of x plus 1? What can we plug in to this function? Well, this is a line. The domain of this function is all real numbers. So we have to find the intersection of these two sets. On the number line, here's 0. Find the intersection of all the numbers that are at least 0 and all real numbers. What's the overlap of red and blue? The answer is at least 0. So our domain here is 0 to infinity. And those are our two answers. This is the function. This is the domain. So it's a little strange here. Well, there's a lot of things that are strange here. One of the strange things here is that when we're simplifying, it's this specific step. When you're simplifying, you're sort of hiding what the domain is. This and this are not actually technically the same, because the top thing can't take in negative numbers, but the bottom thing looks like it can take negative numbers. So that's why the domain of this function is not exactly what it looks like. And that's why we have to use this step to find the actual domain of this new function. And that won't come into play too frequently, but it's something to comment on. Let's do part B, the domain of h of g. And again, since I want to have these same functions before, h of x is 1 over x minus 1. And g of x was the square root of x, just so we don't have to page back and forth. So we have to first evaluate this function. We have to first say, what is hog? So the definition of function composition says h is our outside function. And we just plug g of x, the inside function, into h. Well, what is this inside function? It's the square root of x. So plug it in. This gives us h of g of x is equal to the square root of x. They are the same thing. Replace that g of x with what it equals, the square root of x. Plug it in. And now we look at h of x. H of x is this function. 1 over x minus 1. That's h of x. But we're replacing, right? Replace all the x's with what's on the inside. So replace all the x's in h. There's only one x in h. It's right here. Replace that x with the square root of x. Write it out a little nicer. This is 1 divided by the square root of x minus 1. And some people require you to rationalize the denominator. I'm not going to require you to rationalize the denominator in this class, okay? But you could here. You would multiply. So you don't have to write this down, but if you wanted to, you'd multiply by the conjugate of the denominator like this, and it would simplify out and be some extra steps, but it's not important for me. This is one of our answers. Now to find the domain, it's the intersection of the domain of the inside function and the domain of the simplified answer. We have to find those two domains. The domain of the inside function, is g. And just like before, that's going to be 0 to infinity. What's the domain of this simplified answer? Well, there's two things happening here, right? The domain of this function is denominator can't be 0. Right? Any fraction, we have a requirement that the denominator can't equal 0. And the inside of a square root has to be positive. So there's two things happening here. More 3.2 stuff. The second one's already done. In fact, these are the same. So we just have to look at the first thing. Square root of x, add 1 to both sides, not equal to 1. Well, we can square both sides and get this is true when x is not equal to 1. So we bring out our number line again and say, what's the overlap between red and blue? Red is everything to the right of 0, including 0. And blue is everything except 1. What's the overlap between red and blue? It's going to look like this. 0 up to 1, and then 1 up to infinity. And that's our domain. 0 up to 1, and 1 up to infinity. This right here is probably going to be the toughest video. There's also some fairly difficult applications as well. The video is already 20 minutes long, so for the applications, see the selected homework problems at the end. All right. I believe that will be 3.4.5. All right, good luck, and please ask me if you have any questions.